Good morning, London. What is your strategy for scaling your estate on AWS Cloud? Imagine you are a DevOps engineer, a platform engineer, or perhaps an architect for an organization who's growing and scaling their presence on AWS Cloud. And you've been asked by your CTO to come up with a plan to grow your workloads and account structure on AWS Cloud. How would you go about it? What will be your plan? If this is the concern for you right now, this is a session for you. My name is Fahad Ahmed. I'm a senior solution architect in AWS. And in this session, I'm going to talk about a series of best practices for operating and scaling on AWS Cloud. Later, I'll be honored to join by John T. Bill from MoneySuperMarket Group, who is going to talk about how MoneySuperMarket has implemented those best practices in their environments. So let's get started. To build on the analogy we started, look at the structure here. It's an apartment block in Montreal, Canada. It looks very complicated, maybe chaotic. A lot of time when customers grow their estate on AWS, it becomes complicated like this. Customer typically pick one workload, deploy in one AWS account, build in production, goes successful. In fact, it goes so successful, they pick another workload, deploy, and go so on and so forth, and it organically grows into a complicated structure. It works perfectly fine. It's giving you business benefits, but there are room for improvements, there are efficiencies you can gain, and that's what we are going to discover. So the talk is divided into three parts. Part one is laying the foundations and some best practices around those. Followed by, once you have laid the foundation, some scaling strategies and best practices around scaling on AWS. And then last part is MoneySuperMarket Group use case. So the first part, laying the foundation. A lot of time when we speak to our customers, a lot of time when we speak to our customer, we heard common challenges in terms of the foundation on AWS. The first challenge we often heard is the operating model. What is an operating model? It's a definition of roles, responsibilities for your operations in the cloud. Now, you may not be missing an operating model. You have an operating model, but it may not be evolving as you grow your workload on AWS. So that's one challenge. Followed very closely is the deployment. So how deployments are automated. Are you using the best of the cloud? Are your processes taking same amount of time to deploy in terms of the effort and time, or are they more efficient? The third challenge is autonomy. That's engineers or developers' autonomy. What we're talking about here is the efficiencies or inefficiencies. Do the developers have enough permissions in their account to carry out experimentation and deploy quickly? And then very similar to that is the service enablement. Does the account provisioning take days, weeks, or months, or much quicker? And once the engineers have accounts available, can they use the services on AWS they want to use? So all those four challenges actually can come down to one best practice that we can look at the first one. So the first best practice is define your operating model. Now, to define the operating model, I will take you to a series of three different models, which are three different extremes. There's a QR code on the top right you can scan and read offline as well. There are far more details than what I'm going to cover. And also to mention, throughout this session, there will be many QR codes in various slides. If you're unable to scan it, it's fine. In the end, I will be sharing the consolidated resources as well. So let's start with the first operating model, which is the sustained operating model. So this is also called traditional operating model or centralized operating model. In this operating model, we have separate teams for application engineering and operations and separate teams for platform engineering and operations. Here, platform engineering could be an evolution of infrastructure engineering team on your on-premise. For instance, hypervisor teams, storage teams, networking teams, to name a few. So this model is quite useful if you are doing a lift and shift on AWS Cloud. If you are moving to the AWS Cloud and you want to evolve and lift and shift your operating model, this could be a first starting point. Let's look at another model, which is decentralized DevOps. Totally different extreme. Here, the application engineering team has has a lot of more responsibilities. They're responsible for application engineering and operations, but also the platform engineering and operations. Platform engineering team still exists here, but in a reduced capacity. They're creating a scaffolding and boilerplate codes for them with some guardrails so that application engineering team is not causing any organizational risk. But then the application engineering team is maintaining their own product backlog, which is comprised of applications, infrastructure, and platform. So they are responsible for the whole customized infrastructure. It's called decentralized because the platform engineering is decentralized from the centralized model here. And then finally, the next model I'm going to discuss is a distributed DevOps, kind of a mix of two. Here we have two DevOps teams. One is the application engineering team, who is the DevOps for application engineering and operations, and then we have platform engineering DevOps for the platform side. You can think of this as a shared responsibility principle or model, whereby the two teams are working together to give business outcomes. Here, the platform engineering team is creating opinionated, codified infrastructure and account provisioning structure for the engineering team with all necessary guardrails baked into it. An application team does not have to worry about the underlying heavy lifting and what's going on in the infrastructure layer. So these are the three operating models. And the third, just to mention, the decentralized DevOps could be quite useful if you are refactoring on AWS or if you are modernizing your infrastructure. Whereas a decentralized distributed DevOps can be quite useful in the situation where you want to have standard accounts across multiple workloads, and you want to make sure that your account and application team does not have to worry about the underlying infrastructure, and you take away the cognitive load away from them. So that's where you can use these operating models. But once we have defined the operating models, the next best practice which I'm going to discuss is align your operating model with the multi-account strategy. Now, there are a few things going on here. What is an account? What is a multi-account? And what's the strategy? So let's look at those. So AWS account is a logical construct, a logical boundary or compartment where you can segregate or isolate your workloads, resources, cost, access, and security from other workloads in other accounts. In the apartment block I mentioned, so each apartment can be treated as an account. But if you have an account, why do you need multi-account or multi-account strategy? Can one account not enough? Surely one account means less management overhead. Let's look at why multi-account is a good idea. There could be multi-reasons. One is if you have multiple workloads, the responsibilities could be, with multiple teams for multiple applications. So the ownership can dilute if you have one account only, who is owning what part of the account. Similarly, the IAM policies and roles and policies can be quite complicated if you have multiple workloads in the same account. And then resource sharing can become sometimes can become an issue. The second reason, which is not the pure reason of going multi-account, but it could be one of the reasons, is billing and cost. You can achieve same through tagging or segregation within same account, but it could be a reason. The next one is a big one, isolation and security. So you may have heard about the blast radius. So if you have one workload in an account which is shared by another workload, one workload can cause disruption to another workload which you may not want to do it. So that could be one reason. Another concept in AWS is the service limits. We have soft and hard limits per account in a region. And if multiple workloads are sharing the resources, you may hit the service limits sooner, which may impact your workload reliability in production, potentially. And then finally, the main point here is if you are growing your business, if you're scaling your business, and you want to reflect the same on AWS, the best practice is to go for multi-account. Now that we have defined multi-account, but we don't want to go in that chaotic structure, how do you manage those multi-account? And that's where AWS organizations come into play. So it's a service for managing multi-account environments. And the way we do it, we define a group of accounts into an organization called organizational units. And we define those based on a purpose. The purpose I'm going to discuss in the next slide. But in AWS organizations, you define account in a hierarchy, and you apply centralized control at that hierarchy level. So for instance, one of the best practice or example of best practice is in front of you. We have a foundational OU on your left-hand side, which is based out of sub-OUs of security and infrastructure. So security OU or organizational unit comprise of multiple accounts. It could be log archival, auditing, security tooling, to name the few. Then you have organizational unit for infrastructure, where you have shared networking and shared services out there. To note, these are not your workload or business workload accounts. These are the services that are shared across multiple workloads. But on the right-hand side, there's a workload OUs called additional OUs, and within that we have sub-hierarchical OUs called workloads. Now, another best practice here is to align your workload organizational units based on your software development lifecycle, or SDLC. So for instance, if your life cycle, for instance, is dev, pre-prod, and prod, you have those OUs. Another sample OUs there is the sandbox. So these are experimental ephemeral accounts. Your engineers are doing local development, experimentation. Once they're done, you take it away. A lot more details is giving the QR code on the top right, as I said, and as I said, I will share the details later as well. So what we have done so far is we said we need multi-accounts, and we said we can organize it with organizations. So what's the starting point for our multi-account strategy? We said let's map it to our SDLC or software development lifecycle, which is there, but how do you now group it? Do you group your accounts based on applications, based on physical business units? Would you have multiple workloads in the same account, for instance? And to answer that question, we have to go back to our operating model, because that will define our multi-account strategy. So for instance, if you remember, I mentioned decentralized DevOps for refactored purposes, where the application engineering team has a lot more responsibility. If you have that kind of operating model in your organization, having one workload per account is the best practice. Why is that? Because your application engineering team is creating their own bespoke infrastructure. They are fully managing the backlog, and that will work really well. There are a few lessons learned here as well. For instance, if your organizations have thousands of workloads, you will end up with thousands of accounts. So even with managed service like AWS organization, it will become slightly difficult to manage. Your infrastructure will become very fragmented. So you may want to mix your operating model and have sometimes multiple workloads share the same account. One of the reasons of that being is not all your application engineering team will be sharing the same operating model. And that's where your landing zone, which I'm going to discuss in next slide, will come handy. Your landing zone will help you switch between operating model based on your workload. Now, the second operating model we discussed was traditional ops or distributed DevOps. Over here, multiple workloads in an account, it makes sense. What's the reason? We want same opinionated infrastructure and account provisioning for multiple workloads. We want to take away the heavy lifting from engineering team and focus on application. So if you have multiple workloads, you can achieve that through single account, and your platform engineering team will segregate those workloads through like ABAC or attribute-based access control, or VPC, or service security groups, to name a few. Now, the lesson learned here is, if you're going to go on this approach, you may end up with workload sprawls within the same account, and you may end up with those monolith accounts. So you have to avoid those as well, because the service limits, the blast radius will still impact. So again, we are saying sometimes you may have to look at your workload and the operating model physically and say maybe we need one account per workload. For instance, if your workload is critical in nature, you may not want to share with other workloads in the same account, and hence you will be switching operating model. But it should give you a good mental model of where to start, actually. And as I said, there's a QR code which will give you more details around that. But now that we have defined our multi-account strategy based on our operating model, the next best practice, or third one in this space, is centralized governance to distribute and customize control. What we are saying here is that now that we are managing account through AWS organization, we want to make sure all the similar guardrails and processes are baked across all accounts. And the service you can use in this regard is called AWS Control Tower. It's a managed service for managing multi-account environments. To note here is that you can achieve similar things without a managed service like Control Tower. There's nothing stopping you. If you're doing it today, there's nothing wrong with it. It's just that it's going to take away the undifferentiated heavy lifting. It's going to give you more time to focus on your business application. And your Control Tower could be one stop for various things, like it could be single entry point for all your landing zone and all the accounts within the organization. You can establish controls, be it detective controls or proactive controls or preventive controls through Control Tower. You can enable automatic account provisioning through Control Tower and then centralize your logging. But let's put that in practice. Let's look at a prescriptive guidance now of how can you use Control Tower to build a landing zone and a multi-account strategy using your operating model on AWS, which is the next slide. Right. I will caveat before building the slide is that this is going to be a very busy slide, and I don't want you to take away everything technically what's happening. I want you to understand logically what's the construct behind the scene, what's the reasoning behind it, and then you can use your own tooling, your own services, whatever you want to do in your account. So let's start with. We're going to start with our software development lifecycle. We said, so dev, UAT, prod, for instance, we are going to deploy our workload in those accounts, okay? One of the best practices is never to have the developer tooling like CI/CD pipelines on the same workload account. It should have a separate account, and that's where your platform engineering team can potentially create a separate account structure, which has all those toolings baked into it. Your platform engineering team may also be creating an opinionated, codified infrastructure with the tooling of their choice, be it CloudFormation, CDKs, or Terraform, to name a few. And they may host those in an internal developer portal. Your platform team may also be enabling Control Tower. That's a centralized enablement of Control Tower, and they will enable a lot of guardrails through that. I'm going to build a few services here. You don't have to understand those services, just the concept again here. So they can do centralized logging through audit logs through CloudTrail, which is integrated with Control Tower. They can do various kind of control enforcement on all deployed accounts. So for detective, they can use AWS config. They can use CloudFormation and AWS organization service control policies for preventive and proactive guardrails and controls. They can create service cataloging, and then finally, the platform team can create runbooks that can be used by operations. So that's all what your platform team has created for the engineering community. What's the developer experience looks like? So your engineering team will first start with experimenting in the ephemeral sandbox account. As I mentioned, that was a separate OU. And they will be getting access to AWS services through AWS Identity Center. If you want to use it, they can be using CLIs, SDKs to call AWS services. Once they have done the local development, they are ready to push on higher environments. They are going to use the same infrastructure as code and CI/CD pipeline, which your platform team has already provisioned in the DevTools account. So that's where they're going to deploy it. So your workload is coming from experimentation all the way to production now. So if it's in production, now we talk about operations. And that's where, remember I said, runbooks through Systems Manager, which is integrated with Control Tower that your platform team created. That's where your developers and operations team can use runbooks on an ad hoc basis or on a cadence to do the operations. So what we have just done here is we have built the whole operating model through Control Tower, starting all the way from sandbox account into the production with the help of both platform engineering team and the application engineering team. So this is taking care of the 3 best practices we have discussed this far about the foundations. Now that we have laid the foundation, we are going to the part 2 of the talk, which is now we are talking about operations at a scale and what are the best practices here. So we are talking operations here. And whenever we talk operations, we at AWS usually talks about stress testing our operating model. Remember, we started our foundation with the operating model, and we are basing our scaling on the operating model as well. So that is very important. And typically, we ask 4 questions here. 1, what are our ops pain point? If we don't know the pain point, we can't address it, right? Second is, how can we scale? Third is, what are the repetitive tasks? How can we do automation? And then finally is resiliency. How can we improve that? And let's address each of them one by one in subsequent slides. Ops pain point. So over here, we are talking about identifying the pain points and then prioritizing them and put them in a product feature backlog. We want to make sure that this is properly recognized. So in AWS, for instance, sometimes our sprint can contain up to 30% of the sprint working on these ops pain points because they are so important for achieving those operational excellence. And one of the mechanisms you can use to identify and prioritize your pain points is ORR, or Operational Readiness Review. So this has stemmed from our well-architected operational excellence pillar. So it's a formal list which you can codify in best practices and run on a regular basis and involve all your engineering teams. You can ask sample questions in this readiness review. For instance, if multiple workloads are there, is one workload is causing conflict or issues when it's a bad day? So basically, we are talking about retry logics, back office strategy for multiple dependencies. You can ask this question. Another one is throttling. So if you are having a problem in your application, what is the outcome? What will be the effect of the whole on the whole application? Similarly, what is your alerting strategy? Are you over-alerting? Are you under-alerting? Who are the recipients of those alerts? So these are the reviews, questions. They are not exhaustive. You can look at the operational readiness review details. But that leads us to the next best practice, which is annually, or on a cadence of your choice, run operational readiness review. There's a white paper on the well-architected you can review offline, should you like to. But now let's go back to those stress testing our operating model. We talked about the ops pain point. The next one was automation and repetitive task. In AWS, again, we think 90% of the manual tasks can be automated. But again, it depends on your workload, your operating model. But we should have a target in mind. Then the process is identify those repetitive manual tasks, document them, i.e. create the runbooks, and then in a cycle, pick one process, automate it, and so on and so forth until you hit the target. There are many services available out there on AWS and outside you can use. But again, the point here is do some automation. I will talk about a service shortly as well on AWS on this space. But last point on the ops pain point we talked about, or the stress testing we talked about, was the resiliency part. Now, resiliency is a big talk in its own right. It will take a 45-minute session. And there is actually a 45-minute session later this afternoon in this theater. But I'm going to only touch base on one point on the resiliency, which is feature flagging. Feature flag is nothing but a knob or a dial which you can turn on and off, switch on and off in production without impacting your application, and in turn, hopefully improving your application resiliency. Things you can put behind feature flags are like kill switches. So if you introduce a new service, you put it behind a feature flag and turn it off when it's not required. You can do verbose logging if there's a security incident. Once it's finished, you can turn it off to reduce the cost on logging. Similarly, you can have allow block list. This is not an exhaustive list, again, just to give you an idea. But the best practice here is think ahead of time and build feature flag in your application to improve resiliency. Again, there's a blog post on the AWS service. Service matter less here is the concept that you should think ahead of time. But on the service side, AWS Systems Manager is a service which you can use. It has 17 plus features, most of them free of charge. And you can use that as a single pane of glass for all things operations. So it could be used by your native applications, hybrid applications, on-premise applications, single pane of glass. You can use app config, which sits under the application management part of the service for feature flagging, for instance, or you can use change management automation for runbooks. Right, so this is where I have explained the scaling part. The best practices were feature flagging and operation readiness review. Now let's see how we can put those best practices in a real environment. So let's welcome Jonty from MoneySuperMarket Group, who is going to make it all real for you. Over to you, Jonty.
Thanks, Farhad. Morning, everyone. So my name's Jonty. I work in the platform team at MoneySuperMarket Group. So what am I going to talk to you about today? I'm going to talk to you a bit about our current uses of AWS and how that's structured and some of the challenges we've faced with some of the technology decisions we've made over the years. I'm then going to talk about the decision we made to start looking at how we build a new landing zone and how we can land all our workloads and systems into that over time. And then as a consequence of that, we'll talk about some of the takeaways and the things we learned about how we could do that faster. So just a quick bit of scene setting. Who are we? MoneySuperMarket Group. So we're a number of consumer-facing brands. We're on a mission really to save people in the UK as much money as we can. We have MoneySuperMarket.com, which is a price comparison site. I think we saved people about £2.7 billion last year on their bills. We have Quidco, which is a cashback site. We have about 5,000 consumer brands. You can come on, purchase goods through our service using our partners and get rewarded with cashback. We also have Money Saving Expert, which is our consumer champion site that offers unbiased advice to you about how you can make the most of what you do. I think we also send out sort of weekly tip emails that reach about 9.1 million people. And then we also have Decision Tech, which is our B2B technology function, which provides some of our technology to third parties. So we've been around quite a long time. So we're sort of a survivor from the first dot-com boom. We launched our first website back in 1999. We were in data centers, as everyone was at that time. But we did actually adopt AWS quite early, back in 2012, where we put all of our workloads onto EC2. We then followed that up with adopting Kubernetes in 2018, and then went on to then start experimenting with Lambda in 2019. Obviously, nothing happened in 2020, so I won't talk about that. But we did see that then we started to adopt more and more serverless systems. Actually, some of our key platforms now run on serverless, and we launched those in 2021. That takes us up to sort of 2022. Now, at this point, we're about 170, 180 engineers running sort of 20 to 30 teams. And it gets us to quite an interesting situation. So I'll talk about almost our operating model and teams. So here we are. So we actually found, because we invested quite heavily in Kubernetes, we saw quite large platform operation teams where we were seeing cluster operations, CI/CD operations, where we were actually building and managing services on behalf of customers, and we saw a large infrastructure and sort of security operations team as well. So that then led to our product teams that were building stuff on behalf of the customer, where they were aligned in separate silos, and we actually saw that different silos had different operating models. These silos were aligned around verticals or business channels, so car insurance or travel insurance or something similar. And it was actually really challenging for us, where we saw that each one of these teams was operating differently, and there was different requirements on the platform team, and therefore we saw different challenges in what we do. So I'll talk a bit how that manifests in our account structure now. So a lot of our early accounts haven't really changed much since 2012, and they are very much built like a data center in the cloud. So all of the environments in one place, a very challenging set of controls, very difficult to manage. So if you want to enact change, there's usually a lot of meetings involved, so it's quite difficult. We also acquired a number of other accounts, so sometimes via acquisition, sometimes through deliberate creation, and these were all organized slightly differently. So it's quite difficult to manage. What we did see is we did back in 2021, we did introduce Control Tower, which actually really helped us manage some of the overarching control framework, but it's quite hard. So today, sort of when we look at 2021, 2022, we're managing about 350 different technical services or microservices, as it were. And most of our structures look like almost like a traditional data center in terms of how we manage it. So I'll talk a bit now about how those challenges manifest a bit more with an example talking about Kubernetes. So this is sort of an example toolchain. It's quite complex. You can see that this is a Java application that gets built by Jenkins, which is a traditional CI/CD tool, deployed using Argo CD for continuous delivery into a number of Kubernetes clusters. In one of our main production clusters, we've got about 140 different services running that are all built by different teams. For those 140 services, we see about 15 different configuration repositories that may tell you where it is, and then we see about 5, 6 different types of configuring Helm, which is the thing that configures the service. So you can see that sort of multiplies up quite fast and gets to a high level of complexity. What we found, it's incredibly hard to troubleshoot these problems, and over time, teams actually started to shy more and more away from actually looking at the whole thing end to end. So most of our engineering teams were just focusing, I care about my code, I write my tests, it works, oh, the build's gone, I don't worry about it. A lot of these teams never even looked at AWS, which was a real challenge for us because we wanted people to use serverless. So a real issue. And I think we found it's very much like when you're troubleshooting services that haven't had a huge amount of love for a couple of years, you find yourself slowly shifting through the layers of GitOps and config, and it's actually like architectural archaeology in some ways, so really challenging. So that was sort of where we were. And so we made a decision to sort of say, okay, we need to go back to sort of ground zero and build again. So we wanted to build a new landing zone. A lot of this kind of operational quagmire we were dealing with is just something we just said, we don't want to deal with this anymore. Coupled with the fact that we wanted to do more serverless, it actually, although we'd done some serverless platforms, it became very costly to build and deploy those because they use a radically different kind of permissions model. You need to have full access to AWS. It was really challenging to do it with any of our current accounts. So we needed new accounts. That coupled with the fact that we actually wanted to change our operating model as well. So we wanted to stop moving away from these silos aligned around business verticals and build common capabilities for the business. So this was a good opportunity for us to change, and we wanted to say, how are we going to change? So we thought very much about, like, let's take some principles about how we want to move forwards. Some of that were really around things like, we only want to build that differentiates us and allows us to save and deliver value for customers. You know, Amazon talks about undifferentiated heavy lifting. We were doing quite a lot of that at the time. We also wanted to make sure that when we did build new things or do stuff, it was in a way that didn't break everything else. So we want to make sure we can make these open decisions and do stuff in isolation without having wide-ranging impact across loads of teams. We also wanted to think that automation needs to be baked in from day zero. So really, really important. So what does that mean for an operating model? I've got a sticky clicker. So what it meant is we had a thinned down platform engineering team. We wanted to still keep that capability, but we didn't want to be spending all of our time dealing with BAU activities, patching, services, managing other people's pipelines. We wanted to have a series of common platforms on top of that, and then we wanted to have these kind of value-aligned experience teams really working on behalf of the customer much more, rather than just internally focusing on, oh, I've got to do all this admin work or extra things or toil that I have to do as a team. So trying to get people very customer-focused. What did that mean for operating model? We wanted a consistent one. We were very much probably more of a mirror around distributed DevOps. But what we're finding is that when you move to sort of more of a serverless operating model, where we say we want teams to use serverless, and when I talk about serverless, I'm not just talking about Lambda. We mean that we don't want you to use monolithic, centrally managed tools and systems. So no central clusters, everything distributed. So for us, it was very much a steer towards Amazon ECS and AWS Fargate as an option for containerized workloads. Plus containers without the clusters. It really helped us to reduce both the operational toil on platform and on application teams. So a big thing for us is then, okay, we've done that, how do we get our teams to go faster? So we really wanted to make it as low friction as possible for engineering teams. We kind of wanted to make it so engineering teams didn't have to have as much in their head, so they didn't shy away from looking at the big picture. So it should be simple and easy to understand. We want to make sure that when an engineer joins us as a business, it looks familiar. So we don't want to build a highly opinionated platform as a service. We want something that looks like an Amazon immersion day, where the guardrails and the controls and safety's there, but it's not radically different. You don't have to jump through hoops. You don't have to go and speak to some special internal vending service to get a token. It should just work. And we wanted to make sure that when developers got access to those environments, it was all self-service and they could do what they wanted to do without having to have another meeting. So how did that work? We decided very much to build a platform as a product. We got some help from AWS Professional Services, which really set us up to succeed. We made that decision to build a developer-focused infrastructure product. That means Amazon accounts, you can go, hey, can I have an account? You get one, and it's configured in a way that works. But we wanted also to make sure that we had guardrails in place and guidance for teams, so that it was really much focusing towards that serverless first operating model. We didn't want to be running a bunch of VMs. So let's talk about how we built that and how we evolved our usage. So this is quite a lot. This is AWS Control Tower's account factory for Terraform product. There's a QR code that actually goes to the docs. This is a product that's built using Terraform and loads of other automation tooling by the AWS Control Tower team that allows you to stand up and manage Control Tower and all of the customization frameworks that sit with it in a way that has an extremely high level of automation. So for us, it gets to the point you've got 4 code repositories, you've got a bunch of native AWS tooling, and you can provision accounts within minutes and get them customized with your own control framework. So it's that extra layer of automation that means we don't have to worry about toil when we're managing hundreds or thousands of accounts. So we've got a way of provisioning accounts. What do we do about our account strategy? So we chose to focus on these things. We talk about workloads a lot. We've not defined what a workload is really. It's not just an application, it may be more than that. We said every workload gets 3 accounts. You get a dev, a prod, and a staging. We didn't want to do staging, but there's business reasons we have to. And what we found is that you have to focus on the technical service, not the team, the person, or anything else. If you bring your social elements into your account structure, you will cause yourself so much pain. So please don't do that. Please name it after the thing you're deploying. And that comes down to what is a workload. For us, it was really important to understand effectively a change boundary. So if you've got services that talk to each other a lot or change together, so if you have to make a feature and you're saying I have to change this service and this service, they should probably be in the same account. And that's the approach we took. One of the challenges around this is accounts aren't free. We don't talk about it a lot when we talk about multi-account strategy. Our baseline cost for an account is about $26 a month. So a workload is about $75 a month without doing anything. A lot of that comes down to things like observability tooling and other stuff, not just the Amazon cost, there's other things associated with it. But that's just something to be aware of. There is a cost. We felt that was warranted based on the advantages of having lots of accounts. So the trick is also, how do we make it simpler? So one of the things we talked about was reducing cognitive load on engineers. The important thing for us is to make sure that when engineers go into accounts, it makes sense to them. So some of the things we did is like every account in our estate now is the same. Production, dev, everything else, same set of controls, same tooling, all works the same way. It's consistent. We also we've made some really sort of straightforward and clean assumptions around things like IAM controls, identity controls, access management. We only deploy 4 roles every account. So we have a read role, a view role, a write role, and an admin role. Admins break glass. The other ones you get birthright access in non-production, and you get birthright access to view in production, and then you have to go through a privileged access management process to get higher elevations. So it works really well, and it's just consistent, and it's easy to understand, and you move away from having 5,000 roles on an Amazon account, which one of our existing accounts does have. So we did that, and we also need to make sure when you provision these Amazon accounts, you have all the automation enablers there by default. So shared parameters, we can share stuff with SSM now, which is great. You have all your configuration, you have your network, you have your DNS, you have your certificates, everything's there and ready to go using a standardized convention. So what this is actually is a form of abstraction on top of AWS, where you provide an abstraction that the engineers can understand and isn't going to cause them too much pain to work with. And one of the key things we talked about, that actually is quite complex in these kind of environments, is what do we do about networking? So we made a decision to do shared networking, where we provision and manage all of the VPCs centrally in one account. And then what we do is use Resource Access Manager to share those subnets with the workload accounts. So engineers don't have any access to the network at all, and they just provision systems into accounts using shared subnets. This is great because it massively reduces the complexity, also saves a whole bunch of money on costs that come to do with transit gateways, connections, and a bunch of other things. There are some caveats with this approach, which if you are a business which like regularly sells business units or hives off chunks of your systems to other people, this is a really costly thing to undo and change for engineering teams if you've got a lot of applications deployed in shared subnets. But for us, that's not an issue. So we've talked about some of the controls. I'll talk about what it looks like creating a new workload. We usually spend about a day arguing about what to call things and getting the required approvals in place. And that's usually a ticketing-based process or a discussion with a team. And then when it comes to we've got a decision, there's something on the audit trail that we're going to create a new account, it goes to the engineering team, my team, and we can get it done. Usually we get 3 accounts, provisioned, customized, ready to go within an hour. It's all automated. And people then get an email say, hey, welcome to your new accounts. And you can just crack on. So let's talk about, assuming people have got their accounts, now what do they do with them? How do we accelerate change? How do we get people to use them faster? So I'll take us back to what we talked about around Kubernetes and team focus. So teams are very much focused down here on the left. It is the left, yes it is. Good. And you can see that we want people to think about the whole picture. So that means understanding their entire tool chain. So what we wanted to do is think about what's a simple way that we can give teams understanding of the whole thing end to end. So there's a term people may have heard which is talk about, some people talk about paved roads, some people talk about golden paths or different approaches, which is basically say where we have a common strategy that we say within platform, we're going to support, for your choice of running containers, we will support these 5 different ways of doing it, or one way of doing it with 5 different technologies. And that's what we say is our paved road for teams to adopt this technology. And one of the key things people don't talk about enough is it forms a contract between what the platform team does and the wider organization does and what the expectations are of engineering teams. But one of the key things to make is when you're deploying this strategy, it's not a mandated thing. It's an approach that says, this is the way we'll support. If you really want to go off and do your own thing, great. If it's useful and you learn things, please bring it back to us and we can include it for everyone else. What we found is that we then implemented this as almost like software templates, where we went forwards and we actually built a thing that we then shared with teams that they could then use and treat as an example and as a learning experience to then understand the whole picture end to end. This is our context around a containerized paved road for us, which is we made the decision to go Amazon ECS, AWS Fargate, CDK everywhere. So everything within one code repository, your application code, your infrastructure as code, monitoring templates, PagerDuty config, everything in one place that just works for teams. And what it enables us to do is then teams actually start to understand the whole picture and understand the whole thing. Some teams actually find that quite challenging, but it's a process we go through and it really helps them to be able to get into it and look under the curtain, which you can't do in a lot of Kubernetes environments, and actually understand, okay, well, what is wired up to what and how does it work? So how do we do that? So we use a number of different sort of open source tools to do software templating. So we've used something called Copier, something called Cookie Cutter, find them on GitHub. But it means that we can really rapidly scaffold applications for engineering teams. So they can go, hey, I'd like a new application. They can fill in a CLI or a form on a website, and they can get a Git repo provisioned with their example application that's configured how they want it, that's already wired up to the accounts they've just had created by Account Factory for Terraform. So we're really well. And we get to the point where with some teams we'd go, yep, they've got their accounts, they want to provision a paved road, and they get up and running with a Hello World in production in about 20 minutes. And that was a massive win for us. One of the things we did find with this kind of approach around paved roads is some teams, because they're so used to being focused down on just on their own code base, they almost treat the paved road as a software dependency or a platform, when in fact we want it to be much more of a learning experience for teams, and that can be something to watch out for and a bit of a caveat. So how do we get people to start using these tools? That's the question really. So we actually use something called experience-based accelerators, which is something that AWS has as a program of work or sort of a session they run. There's a QR code there, it goes to the guidance around it. We had help from professional services with this, where this is a 3-day sort of condensed workshop-based / hackathon thing, where teams can get hands-on with the new technology and being supported going through from, I've got an application I want to migrate, to then having that application live in production in the next 3 days. And it means we put the engineering teams there with people from platform, experts from AWS, and run through that curated process. And we found it was a really good way of getting those teams on board and up to speed. They used paved roads. They vended a paved road, they took their existing application, put it in it, and then deployed it. And it worked really well. So, you know, that's had an impact on us as an organization. We ran it through 10 teams in Manchester, 10 teams in London, and those teams now, sort of 2-3 months later, we think we're about 25% through our migration now. It says 20 here, it's a bit better now. So it's actually really running really well without us having to be there with a big migration plan to just try and push the teams and get them to get on board with it. So really useful for us. So that's a quick recap, a bit about us, a bit about our historical usage of AWS, how we prompted a decision to make change to try and accelerate what we're doing, what that change looked like, and then a few tips and tricks about how we help teams get on board that journey and go through the change. So I think I'm going to hand back to Farhad now, who's going to do a wrap up. There we go, sir.
Thank you, Jonty. It was amazing to see how MoneySuperMarket has implemented Lending Zone in such a short amount of time. I will wrap up with the thought I started, and I ask you a question. What was your strategy for scaling your estate on AWS? And I'll finish off with a quote from Michael E. Porter, which says, sound strategies start with having the right goal. And the goal in this instance is having an operational excellence and resilience on a scaled state on AWS. And to achieve that, we talk about 5 best practices. Let's recap them. We talk about defining your operating model or evolving your operating model. Then we said, let's map that to a multi-account strategy because you do need multi-accounts. Then we said, let's distribute the control through Control Tower. Then once you are in production, talk about operational readiness review. And we talk about EBCs there. And then finally, look at resiliency. Feature flag was a thing we discussed here. One last thing to mention here is we are running a skill builder, platform-based service, subscription-based service where you can learn about AWS. 7-day trial is on offer right now. And you can learn all or everything we discussed today here as well. And on that note, I would like to thank you for your time and attention. My and your Jonty's LinkedIn profile is there. I'll be posting all the QR codes we had discussed in my LinkedIn post later this afternoon. And please do fill the survey, which is the right side, big QR code. We do appreciate your time because these data points help us understand what went well or what could be improved. We have a ProServe team here. We have MoneySuperMarket engineering team, account team for MSM. If you need anything you want to discuss further, please do reach out to us. We'll be hanging around here. But thanks for your time and enjoy your rest of the summit. Thank you.